Problem number 1. What are the minimum and maximum values, respectively, of the equation f of x is equal to 5x cubed minus 2x squared plus 1 over the interval minus 2 to plus 2. Okay, be a little bit suspicious because we could be looking at a problem where the maximum and minimum that we think we can find by calculus may not be the actual answers. It may be at the extreme ends. Let's see what happens. The first thing I do is I differentiate this function. F prime of x is equal to 15 times x squared minus 4 times x. I set this equal to 0, and I get then that x times 15x minus 4 is equal to 0. So the solutions are x is equal to 0 or x is equal to 4 over 15. Now test to see if I have a maximum or a minimum or an inflection point. So I take this and I differentiate again. F double prime of x is equal to 30x minus 4. Now let's test this and see what happens at x equals 0. So at x equals 0, f double prime of 0 is equal to minus 4. Conclusion: since the second derivative is negative, then this point must be a maximum. So let's make a note of this. MAX. Maximum because of the negative result we get here. Now let's check out the other point. At x equal to 4 over 15, what happens to 30x minus 4? Well, f double prime at 4 over 15 is equal to 30 times x. That would be 30 times 4 over 15. That's equal to 8 minus 4, which is plus 4. That's positive. Since that's positive, it tells me that this point here must be a minimum. Now, these could be local maximum and a local minimum. I need to check the endpoints of the interval to see how they compare. So let's take the original function and go to the endpoint x is equal to minus 2 from over here. At x equals minus 2, I find that the function at minus 2 has the following value. It's 5 times minus 2 cubed minus 2 times minus 2 squared plus 1. That's equal to 5 times minus 8, that's minus 40. Minus 40 and minus 8 is minus 48 plus 1, minus 47. Minus 47, that's a lot less than the 4/15 that I thought I had over here as a minimum value. This is a lot less than this number, so this looks like a winner to me. Let's see what happens at the other endpoint. At x equals 2, the function at 2 becomes 5 times 2 cubed minus 2 times 2 squared plus 1. It gives me 5/8 of 40. 40 minus 8 is 32. 32 plus 1 is 33. I get 33. Looks like I have another winner here because the 33 is a lot bigger than the value I thought I had found. Let's check them out. These are two endpoint values. I'm getting a minus 47 over here, and I'm getting a 33 over here. What about these values we thought we had? When x is equal to 0, this function is simply equal to 1. That 1 is pale in comparison to 33. So x equals 0 is not the maximum. Looks like x equals 33, or x equals to 2, will give us the maximum. How about in the minimum department? When I put 4/15 in here to evaluate this function, I'm getting that the value of this function at 4/15 is equal to 5 times 4/15 cubed minus 2 times 4/15 squared plus 1. That's equal to 0.95. 0.95. Not good enough. That 0.95 doesn't come anywhere close to give me the value of a minus 47. So the endpoints win in this case, and so I'd have to declare the answers to be minus 47 and plus 33 respectively. And that would be answer A on the answer page.